Hello and welcome to Waterford Stanley's R&D facility, where today we'll be looking at the Waterford Stanley 7 kilowatt inverter controlled heat pump. In a moment my colleague Noel is going to take you through the internal unit.
Hi, I'm Noel Hannon and I'm just going to demonstrate the Waterford Stanley internal unit of its heat pump. So here we have the internal unit. It is approximate size of a fridge freezer. So it can be installed in the kitchen or utility or possibly in a retrofit situation as a replacement in the hot press. So the internal unit requires 300mm clearance up on top just to access the fittings here at the back, and it can be serviced from the front. So it's easy to access from the front. Just remove the two screws on the bottom and then this panel can be lifted off. So when that panel has been lifted off, it reveals two screws here, and again the next panel can be lifted off. Similarly then, for the last panel, there are two screws that can be removed, but the last panel is attached with the cable for the display, so it's not so easy to take it away. Just like to show the display here now for a minute, if that's possible, it can be viewed. At the moment we can see that the heat pump is on standby, so it's not running. The heating is at 50 degrees C, the return temperature is at 47 degrees C, and the domestic hot water temperature is at 52 degrees C. So I'll just take that aside. Now we can see the internal of the heat pump. We have a 200 litre glass-lined cylinder. So in underneath the cylinder we have a 50 litre buffer tank, we have a circulation pump, we have the condenser unit here in the back corner, we have a three-way valve, and we have a backup heater, a 2 kilowatt backup heater. So there are all the components that are located down here, and in addition to that we have all the electrical components up here along the left hand side. So the electrical elements within the heat pump are the contactor, the main control board, web module, transformer, terminal blocks for all the connections, and an octo coupler. The web module allows the heat pump to connect via the internet, so it allows Waterford Stanley to review the data and the performance of the heat pump to make sure the heat pump is working correctly, and should the event occur that the heat pump is not working correctly, it allows Waterford Stanley to diagnose the problem online. All the electrical connections are made up here in terminal blocks as opposed to made on the control board, so it means that the likelihood of damaging an expensive component while making a connection is minimised. The connections are the electrical supply to the internal unit is here on the bottom, and then we have the communication cable which goes directly out to the external unit. And then we have other connections up along here which are for circulating pumps, mixing valves, and the external temperature sensor.
Okay, so this is the top of the internal unit where we're going to talk through the various plumbing connections on the top. And I'll start just by explaining that on the top right hand front corner you can see the serial number of the product is on a label here and can be accessed from there. That label is also on the web module on the inside of the unit as well and can be accessed from there. On the left hand side here there are grommets where the various electrical components come in. So we have our mains cable, our communication cable, and all our various cables coming from our circulation pumps come in on the left hand side and down through the top. Okay, so our plumbing connections then, starting from left to right. On the left hand side we have our two refrigerant pipes coming in, our 3/8 and our 5/8 connections are made here. We then have our mains water coming into the unit through this connection here. The next connection then is a connection which is for recirculation of DHW water, and in this instance it's not being used, so we have that capped off. We then have a 3-bar safety valve coming from our DHW. Then we have our pressure gauge here showing the pressure within the system. We have a vent pipe here, which can be seen here. We then have our flow and returns from our heating circuits. And in the center, we have this connection here is our DHW water coming from our cylinder. Also then on the top of the unit, we have this cap here, and this cap is blanking off where the sacrificial anode is fitted. And the sacrificial anode is for protecting the unit against corrosion. And that's the main connections on the top of the unit. So here in the lab, we have two small circuits running from the heat pump. We have a radiator circuit here and here, and then we have an underfloor section running here. We're using aluminium rads here, but it's fine to use steel rads once they're sized appropriately for the heat losses from the room. So here we're running these radiators at 40 degrees, and on the underfloor system we're running it at 30 degrees. And we're able to control the temperature of the underfloor system via the use of a mixing valve, which is hardwired back to the heat pump, and the heat pump is controlling the mixing valve and telling it to open or close to control the temperature of this zone. And with the use of the mixing valve, this allows us to deliver a higher temperature to upstairs, for instance, and then control our downstairs zone at a lower temperature. So in a moment we move around to the back where the plumbing is, and we'll take a closer look at the mixing valve and just explain how that works and how it interacts with the internal unit. Okay, so we just moved around to the back of the unit to take a look at the plumbing connections that are plumbed in here on our system. So we have our flow pipe here coming from the top of the heat pump, and here is our return line going back from the heating circuit back to the heat pump. And on the return line we have fitted a valve here, a strainer valve here, and we also have a MagnaClean fitted on the return line coming back. So we move across and we'll just have a look at the mixing valve and the circulation pump for the underfloor system, and we'll just talk through how that operates. So this is our flow line coming in here, coming across. It interacts then with our mixing valve, which is here. Then we have our circulation pump for the underfloor heating here, and that's coming out through here, and we have a PT1000 temperature sensor which is monitoring the temperature of the underfloor zone. So the PT1000 and the mixing valve are both hardwired back to the internal unit, so that's constantly monitoring that temperature, and then the heat pump is telling the mixing valve to open or close in order to increase or decrease the temperature of that zone. So basically the mixing valve is just a straightforward T-shaped valve which has an electronic actuator, and the actuator then opens or closes, and as that opens or closes it increases or decreases the rate of flow water coming into the valve. And if it's cooling if it needs to cool the temperature down, it mixes return water in. When the valve opens, it allows some of this cooler return water to mix in with the hot water coming from the flow, and then that delivers a warm temperature to that zone. So the mixing valve has the ability to accurately control the temperature of that zone by mixing return water in with the flow water to regulate that temperature.
Okay, now we've moved to outside and just going to show you the external unit of the heat pump. So here we have a single fan 7 kilowatt unit. It's also available in a double fan unit. So this is the fan unit here, so it's a double fan unit, so it's a taller unit, and that's a 12 kilowatt unit. So the external unit works by moving a large amount of air across an evaporator. The evaporator runs from over here all right around to here, and the fan here moves the air through the unit. Okay, so it's very important that there's free movement of air through it so that the fan can move the volume of air required to generate the heat. So at the rear of it we require clearances. Now this one is installed further out than required. It's installed at approximately 700 millimeters from the wall, but that can be reduced as low as about 300 mil from the wall, but must have at least 300 mil. On the opposite side, on this side, we must have at least 2 meters of clearance to allow again for the air to move freely through it. Now, should the unit be installed against the prevailing wind, it is necessary to put a shelter or a windbreak to allow the unit to expel the air through, because if it's working against the prevailing wind, it won't be able to push the air through the unit and then cannot work at its optimum efficiency. So when the unit is working, the evaporator takes a lot of heat out of the air, and some of the moisture that's in the air will form water vapor on the unit. That water vapor will condensate and can drop down. So it's important then that there is a means of collecting the condensate on the bottom. So the unit is supplied with a drip tray underneath, and there are 5 connections on the underside. These can either be closed off and piped to drain, or in this case we have a soak pit underneath. So there's a soak pit built in underneath where the condensate can drop down and it will drain from here and off to drain. So I have the screws removed from this cover here. This cover can be removed by just sliding it down and then pulling it out at the bottom. I'll set that aside. Now, so here we have the external heat pump with the cover removed, and we can see the 2 refrigerant pipes coming out from the internal unit. So here we have the 2 valves. These valves are used to fill the system and to release the refrigerant into the system. Here we have the electrical connections for the power supply to the external unit, and then here are the 4 connections for the communication cable which goes direct to the indoor unit. Here we can see the main control board of the external unit, and down here we can see the compressor. The compressor is used to compress the refrigerant and moves the refrigerant through the system, and that is what actually changes the temperature so that the heat can be extracted from the air. Okay, here we can see we have a PT1000 external temperature sensor fitted to the outside wall. This is supplied with each heat pump. Should be fitted on a north facing wall, away from any openable doors or windows, so there won't be any external interference on the temperature readings. The external temperature sensor is used for weather compensation. So when in normal operation, the heat pump might supply 40-45 degrees to the radiators at a constant based upon the readings from the thermostats. But in weather compensation mode, the heat pump can reduce the temperature to the radiators supplied based on the external temperature. So if it gets warmer outside, it supplies a lesser temperature to the radiators, maximizing the efficiency of the heat pump.